Picture yourself floating in space, looking up and down from our solar system's flat orbital plane. What you'd see there would blow your mind completely. The universe above and below us harbors phenomena so extraordinary they challenge everything we thought we knew about reality. Recent discoveries from the most advanced space telescopes reveal that vertical space is far stranger, more dynamic, and more influential than anyone ever imagined. Our entire solar system is surfing on a cosmic wave. Just 300 light-years from Earth, closer than many stars visible to the naked eye, astronomers discovered something that had been hiding in plain sight. The Radcliffe wave stretches 8,800 light-years across space and rises 500 light-years above and below the galactic plane, like a frozen tsunami. But here's what makes it truly extraordinary. This massive structure isn't frozen at all. It's alive, actively oscillating through space like a stadium wave at a cosmic sporting event. This discovery shattered our assumption that large galactic structures are fixed and unchanging. The wave contains over 3 million times our Sun's mass and connects the stellar nurseries of Orion, Cepheus, and Cygnus in a unified, breathing cosmic organism. Stars are being born along this wave as it travels through space, making it a mobile stellar factory that creates new suns as it moves. Imagine a cosmic assembly line that doesn't stay in one place, but travels through the galaxy, leaving a trail of newborn stars in its wake. As we journey vertically away from our familiar galactic plane, space itself begins to transform in ways that seem impossible. At approximately 3,000 light-years above or below the galactic disk, something mind-bending happens. The galaxy's magnetic field completely reverses polarity. This isn't a gradual transition, but a dramatic flip that fundamentally alters the electromagnetic properties of space itself. It's as if the universe has invisible floors and ceilings where the fundamental rules suddenly switch. These reversed magnetic fields don't just float randomly in space. They organize into highly structured filamentary networks stretching 150 times the full moon's diameter across the sky. These invisible magnetic highways guide streams of gas heated to 3.5 million degrees, creating what astronomers now recognize as the galaxy's magnetized respiratory system. Our galaxy literally breathes, inhaling and exhaling stellar winds and cosmic rays through vertical channels spanning tens of thousands of light-years. Even more mind-bending is what happens to time itself as we move vertically through space. Laboratory experiments can now detect gravitational time dilation over distances as small as 1 millimeter. This means that simply standing up makes time flow differently at your head versus your feet, though the difference is far too tiny for humans to perceive. But scale this effect up to cosmic dimensions and things get weird fast. Our solar system doesn't just orbit around the galactic center. It also bobs up and down through the galactic plane like a cosmic yo-yo, completing one vertical cycle every 66 million years. During this journey, we pass through regions where time flows at measurably different rates. When we're high above the galactic plane, time passes approximately 1 second per week faster compared to the dense galactic disk below. We're literally time traveling as we move through our galactic orbit, experiencing a cosmic temporal landscape that varies with our three-dimensional position in space. This gentle bobbing seems peaceful until you realize what happens at the galaxy's center. There, the universe operates a stellar artillery system of unimaginable violence. Binary stars that venture too close to our galaxy's central supermassive black hole experience gravitational forces so extreme that one star gets captured while its companion gets launched like a cosmic cannonball. The current record holder races through space at 1,755 kilometers per second, nearly 4 million miles per hour, fast enough to circle Earth in under 23 seconds. Speaking of escaping the galaxy, recent discoveries have unveiled cosmic structures so large they violate our fundamental understanding of how big things can get in the universe. Astronomers in 2024 discovered black hole jets spanning 23 million light-years, equivalent to 140 Milky Way galaxies lined up end to end. This structure, named Porphyrion, is more than twice the theoretical limit for how large cosmic structures should be able to grow. It's like finding a mountain twice as tall as physics says mountains can be. These jets originated from a supermassive black hole 7.5 billion light-years away and may have magnetized vast regions of the cosmic web during the universe's formation. The energy involved is so staggering that if you could harness it for just 1 second, you'd have enough power to run human civilization for longer than the universe has existed. The discovery of over 10,000 similar jet pairs in just a small portion of the sky suggests that such impossible structures are actually common, forcing us to reconsider our most fundamental assumptions about cosmic evolution. But we don't need to look billions of light-years away to find cosmic mysteries. Beneath our feet, embedded in our own galaxy's structure, lies a fossil record more ancient than any earthly artifact. Using incredibly precise stellar motion data, astronomers have uncovered the remains of entire galaxies that collided with the Milky Way billions of years ago. One of these cosmic fossils, nicknamed Heracles, accounts for approximately 1/3 of our galaxy's entire halo mass. This discovery reveals that our supposedly quiet spiral galaxy had a remarkably violent youth. At least 6 major galactic collisions shaped the Milky Way we see today, each one leaving distinct signatures in the motions and compositions of stars. These ancient mergers created the tilted, football-shaped stellar halo that surrounds us, populated by stars that remember their origins in alien galaxies. We're literally surrounded by immigrant stars from cosmic civilizations that ceased to exist billions of years ago. As we probe deeper into the vertical mysteries of space, we encounter phenomena that challenge our understanding of reality itself. Theoretical physics predicts that the vertical dimension might be fundamentally different from horizontal space. According to some theories, gravity in our three-dimensional world might actually emerge from quantum information encoded on two-dimensional surfaces, making the vertical dimension potentially illusory, a holographic projection of information stored elsewhere. The vertical dimension also carries mysterious signals that defy explanation. Radio telescopes detect bizarre transmissions from above and below the galactic plane that switch on and off randomly while maintaining extreme circular polarization. These signals exhibit brightness temperatures that exceed theoretical limits by factors of millions, suggesting either new physics or cosmic phenomena we've never encountered before. Some of these radio ghosts appear for weeks, disappear for months, then return with completely different characteristics, as if the universe is broadcasting encrypted messages we can't decode. Even more puzzling are the neutrino observations from 2023. These ghostly particles should be streaming from cosmic ray interactions throughout our galaxy, but observations reveal far fewer than predicted. Our galaxy appears to be a neutrino desert, producing these elusive particles at rates that don't match any theoretical model. This discovery suggests that fundamental processes we thought we understood operate differently in the galaxy's vertical architecture. The mysteries deepen when we look at the most distant objects ever observed. The James Webb Space Telescope has revealed galaxies that shouldn't exist according to our understanding of the early universe. These ancient galaxies show fully formed structure when the universe was supposedly too young for such complexity, appearing just 280 million years after the Big Bang. They formed 100 times faster than our best theories predict, suggesting that the early universe operated by entirely different rules than we observe today. Adding to the puzzle, astronomers now detect fast radio bursts from ancient dead galaxies that haven't formed new stars in billions of years. These millisecond flashes release more energy than our sun produces in 3 days, yet they originate from cosmic graveyards where all stellar activity supposedly ceased eons ago. Either our understanding of these galaxies is wrong, or some unknown process can generate enormous energies without any of the mechanisms we know about. Perhaps most spectacular are the giant X-ray bubbles extending 45,000 light-years above and below our galactic center, structures comparable in size to the entire galaxy itself. These hourglass-shaped features glow with the heat of past violence, possibly from our central black hole's ancient feeding frenzies. They contain organized magnetic filaments carrying gas heated to millions of degrees, revealing that our quiet galaxy can produce outflows rivaling those seen in the most active galaxies in the universe. These bubbles suggest that all galaxies might be breathing, processing energy and matter through vertical channels that connect galactic disks to intergalactic space. It's as if galaxies are living organisms with circulatory systems that extend far beyond their visible boundaries, pumping processed material up and down through cosmic arteries we're only now learning to see. As we pull back to see the bigger picture, a profound truth emerges. The universe above and below our solar system isn't empty void, but a complex dynamic environment operating by exotic physics principles. Time flows differently at different heights. Magnetic fields reverse polarity at invisible boundaries. Massive structures oscillate like living waves. Stars get launched at near light speeds. Ancient galactic fossils hide in plain sight. Quantum effects might make vertical space fundamentally different from horizontal space.
The vertical light year we travel takes us deeper into a cosmic realm where conventional physics breaks down and nature reveals its most counterintuitive behaviors. The gentle appearance of the night sky masks a vertical dimension filled with violence, mystery, and phenomena that push the boundaries of the possible. As our instruments grow more sensitive and our theories more sophisticated, we're discovering that the most profound secrets of the universe aren't necessarily hidden in distant galaxies billions of light years away. They might be right here in the extraordinary vertical architecture that surrounds us at every moment, waiting for us to look up, look down, and see the cosmos with new eyes. The journey into vertical space reminds us that we've barely begun to understand the universe we inhabit. Each discovery opens new mysteries, each answer spawns new questions, and each observation reveals that reality is far stranger and more wonderful than our imaginations dared to conceive. We live in a cosmos where the impossible happens routinely, where the vertical dimension holds secrets that could revolutionize our understanding of existence itself. The implications stretch beyond pure science into philosophy and human meaning. If vertical space operates by different quantum rules, if time itself flows differently above and below us, if massive structures can oscillate like living beings, then what does this say about our place in the cosmos? We evolved on a small planet orbiting an ordinary star. Yet, we've developed the ability to detect phenomena that span millions of light years and challenge the fundamental nature of reality. The hypervelocity stars racing overhead carry more than just mass and energy. They carry information about regions of spacetime so extreme that matter behaves in ways we're still struggling to understand. Each one is a messenger from the violent heart of our galaxy, a natural probe launched by gravitational forces that would tear apart anything we could build. Yet, we can track them, study them, and use them to map the invisible dark matter that shapes our cosmic neighborhood. Most humbling of all are the signals we can't explain, the radio ghosts that appear and disappear without pattern, the neutrino desert where particle floods should flow, the ancient galaxies that formed too fast and too early, the energy bursts from dead galaxies that should be silent. Each unexplained phenomenon is a reminder that our understanding of the universe remains painfully incomplete.
We're like children who've just learned to read, trying to decipher a cosmic library written in languages we haven't yet discovered. Yet this ignorance isn't cause for despair, but for excitement. Every mystery we uncover points to new physics, new understanding, new ways of seeing reality. The vertical dimension of space has revealed itself as a laboratory where nature conducts experiments we couldn't imagine, using forces we're only beginning to measure, creating phenomena that expand the very definition of what's possible. And the most exciting part? We're just getting started. New telescopes are coming online that will peer deeper into vertical space. New theories are being developed that might explain the impossible structures we're finding. New technologies will let us detect signals we can't even conceive of today. The vertical universe above and below us holds enough mysteries to keep humanity exploring for millennia to come. Each discovery guaranteed to be stranger and more wonderful than the last.